Hi all. Uh, so today's topic is vosk, which is an offline model. Offline means we can run it without internet. Okay, so the model file will lie in your local folder. Okay, so we will cover vosk setup, cloning, virtual environment setup. Then we will go through the vosk models. Then we will do hands-on Python. So let's go ahead with code. So let me walk you through the vox website. Just Google was, go to this link. Now on the left side you see a menu bar. So installation and models is what we will look into. So go to installation. So it will tell you steps for installing on Mac, Windows and Linux. Okay, so let us set up this on our local. Okay, I'm going to clone this repo here. Okay, done. Let us open this. Now we are going to set up virtual environment here. Okay, so you see virtual environment is created. Now we need to activate it. So go to VN folder, scripts. Use this bat file if you are on CMD terminal. So if you see here the PowerShell CMD terminal. Okay, so I am on PowerShell, so I am going to use this file. Right click, copy path, paste it here. Okay, yeah, so our model is activated now. Now we need to install vosk package. So pip install vosk. Okay, so sometimes you will get an SSL error if you are on VPN or Zscaler. So to in pip install, so to fix that you can use one more command. So if you get an SSL error on your company network, you can use this command, pip install trusted host pypi.org, and at the end you put the name of the package was. Okay, yeah. Okay, so now let us go to the model section. So these are the commands. So let us try to run this vosk transcriber. So but okay, so you need to give the path of the file. Okay, of this clone repo. There is one file test.wave, and this is the path of this file inside vosk-api Python example test.wave. So in this command vosk.transcriber minus e, give the path of the file. Okay, and then output file test.txt. Okay, then run it. Yeah, yeah. So it is expected to fail. Now two reasons. Now one is key, uh, FMPG package is required for it. Okay, which may or not be available for you. Okay, second is it loads the model in cache online. Okay, so it's not showing right here loading because already it is available in the cache directory. Okay, but in production setup you don't want to load models on the fly. Okay, and setting up FMPG in Docker also is one more task, okay, with its own challenges. So we will try to do it without this was the transcriber, and in production we need a Python file. So okay, we will go with that approach. So if you go to the URL, uh, so here you see the command. So we have cloned this repo, then we will run these commands, okay, and then see the output. So let's follow these steps. Before running this, let us hear what this input file test.wave actually sounds like. So I'm gonna play this now. Okay, now let's execute the script. Okay, let us install vosk here. Okay, I think it has to do with Python 3. Okay, now it's running. So you see it gives some output. So the actual audio contains 1001902100180. So let us see what it is generating. So what is 100? Okay, 100 10001. Okay, so this seems wrong. 00. Okay, 01803. So partially it got some of the text correct. Okay, so now let us go through the models available. So these are the models. Okay, size and word, error rate or speed, notes. Okay, brief info about the models. Okay, so it has Indian, Chinese, Russian. So you can try all these models. Okay, let us go through the code once. Okay, of this file that we ran, test underscore simple.py, and this repo has multiple uh, files for Java, Node.js, Python. You can try those also. And examples also there are multiple files. Okay, let us go through this code. Okay, so this is the test.v file that is being read here. Okay, and audio file must be wave format mono PCM. Okay, model lang enus, that is this model, giga model. Okay, vosk model enus. Now this you are here getting the frame rate, because if frame rate mismatch is there, it may not convert it to text properly. Okay, okay, so now here we see that where is the model actually. So it is downloaded from internet. Okay, or it is available in cache somewhere, but in the production you don't want to connect to internet, maybe client has access issues. So it is better for offline model. So this is one time download, but that also may be restricted. So here you see you can give the model path. Okay, so let us try with that also, downloading the model. Okay, and then trying. So let us go to website, let us download this model. So it is a heavier model, 2.3 GB, so it is gonna take some time. Okay, so it took me 40 minutes. Okay, so let me just skip it to the next part after download. Okay, so I have downloaded the file here, the model file. Now let us change the path to this file. Comment this and Windows make sure to indicate double backslashes. Okay, so I update the path here. Let us run this. Okay, but it is giving some error. Okay, because we are not passing model name but model path. If you go inside this, you will see model path is one of the variable. Okay, so instead of model name, we will give model path here. Okay, great. Now let's run it again. It actually take a bit of time, which is on a higher side compared to online models also. Okay, now I got it. You see 100 something, yeah, 922. Okay, so okay, we got some result. Okay, now let us try one more file. So we will try harvard.web. So this file only has numbers. That file actually has English text. Again, again to download it, to just search for harvard.web file. Go to Kaggle and click on download. Okay, I'm going to place this file on the same path as test.wave. Okay, okay, so you see harvard.wave is here. Let me run the command again. After we get the result, we will see the actual audio. We will hear the actual audio of harvard.wave. Okay, okay, so we got this error. So let us try to convert this file to mono PCM format. We are going to need FMPG for this, so let us download FMPG. Okay, go here. Linux, Linux. Okay, so I think this is for Windows 64. Okay, so we have FMPG downloaded. Right, so we see this error. Audio file must be WAV format mono PCM. Okay, so let us convert into mono PCM format. For that, we will need FMPG. Okay, so Once you download the FMPG, you need to set the path of FMPG in the system environment variable. So okay, to go to system environment variable, path variable. Now add your path like this till bin. Okay, FMPG slash bin. Okay, then okay, do okay, okay, apply, okay, whatever comes. Then maybe close that terminal and reopen another terminal, and to check that if it is installed or not, you need to run fm mpeg dash version. Okay, okay, so something like this will come, version and other details and no error. Okay, so it is installed now. So let us convert it. So I am on that harvard.wave file path. I am going to use this command to convert this to output.wave file, harvard.wave, using fmpg. Okay, so this is a simple command, so you can get it using copilot. Okay, so okay, so it already exists, so let me overwrite it. Okay, great. So let us try to run with this file now. So file is saved with output.wave name. Okay, so run this. Okay, so conversion has started. So you see some words: cold, dip, pickle with. Okay, okay. The stale smell of old beer lingers. It takes heat to bring out the odor of a cold dip, restores health, and zest. A salt pickle taste fine with the ham, tacos, all pasta, or my favorite, a zestful food, is a hot cross bun. Okay, so let us see what actually Harvard.wave audio looks like, or when we hear it. Okay, okay, let us open this. Let me run this. Okay,
The stale smell of old beer lingers. It takes heat to bring out the odor. A cold dip restores health and zest. A salt pickle tastes fine with ham. Tacos al pastor are my favorite. A zestful food is the hot cross bun.
so that's really good. Okay, exact conversion, I would say, very accurate. Okay, so good. Okay, so that concludes our vosk related part. Let me show you the GitHub repo also. So file structure may be a bit different. So in the data folder, you will have the test files harvard.wave output, which is conversion of harvard.wave to monopcm output.wave. Okay, maybe I will rename it to harvard underscore output.wave. Okay, then test.wave. Okay, then we have the code part. Okay, so this is the code part. So you can use this one if you want to do it online, or if offline you need to download the model and put the model path here. Okay, okay, thanks. So if any questions, or you need to test some few files, other files, or an issue, you can ping me or message me in the comment section. Yeah, thanks for now.